In this video, I'll be helping you with a math topic called Converting Standard Notation to Scientific Notation, seen here in the OpenStax College Algebra 2nd edition text. We're converting into scientific notation, so we'll start with the definition of scientific notation being the form a times 10 to the nth power, where n is an integer, where the absolute value of a is between 1 and 10. So the form that we will always see is a single non-zero digit, a decimal, potentially other digits, times 10 raised to some integer. And the thing to remember here is that when n is positive, we are referring to large numbers, and when n is negative, we are referring to small numbers. And I think this helps with confusion that sometimes comes in around which direction you're moving the decimal place. So looking at our examples here, for A, we have this very large number, which is the number of meters that the Andromeda galaxy is from Earth. So a large number. In standard form here, our decimal is at the end, but in scientific notation, it must be behind the first non-zero digit. In scientific notation, this would be written as 2.4 times 10 to some power. And since I know I'm working with a very large number, and I can count the number of movements to get from the original to the new position, counting, I can see that that is 22 digits to the left that it has been moved. But importantly, it's positive 22 because this is a large number. Moving to B, this time the number represents the diameter of the Andromeda galaxy in meters. So again, a very large number. The original decimal place is here, and in scientific notation, it must move to be behind the first non-zero digit. So in scientific notation, this would be 1.3 times 10 to the number of spaces that the decimal would have to move. This time we have 21 decimal places. And again, it is positive because this is a very large number that we are representing. In C, we have the number of stars in the Andromeda galaxy. So again, this is a large number. Our decimal is originally here, and we need it to move behind the first non-zero number. So this would be a 1.0 in scientific notation times 10 to the number of places that the decimal had to be moved. And here, that decimal would need to move 12 spaces, a positive 12, because it's a large number. However, in E and F, we are dealing with small numbers. Here, the original decimal place is here, and in scientific form, it would need to move behind the first non-zero digit, so it would need to move here, giving us 9.4 times 10 to this time the number of spaces that we would have to move the decimal is 13, and since this is a very small number, I know that this would have to be a negative 13 as the exponent, and that was actually D, not E. E is our last, which is the probability of being struck by lightning in a single year. The original decimal place is here. Moving it behind the first non-zero digit would mean moving it to this location. Our scientific notation format would be 1.43 times 10 to the number of places the decimal is moved, which is 6. And since this is a small number, that is a negative 6 for our scientific notation.